So resonance is a phenomena in which in a circuit the voltage and currents both are is in same phase, and the angle between the voltage and current is 0 degrees, and the power factor of the system is or power factor of the network should be equal to 1. Resonance is a phenomena in which the voltage and currents both are is in same phase for a particular circuit, but for a series RLC circuit, and I am deriving the resonance condition for series RL circuit, and the phase angle difference between the voltage and current is phi is equal to 0 degrees and the power factor equal to 1. The VL is the voltage across the inductor is equal to voltage across the capacitor. From this, I into XL is equal to I into XC, and where XL is equal to XC, XL can be written as omega L and XC can be written as 1 by omega C, and omega R square is equal to 1 by LC, and the omega R is equal to 1 by root LC, and in some of the textbooks he is written as omega naught. And we can write it in another way in terms of frequency. 2 pi FR L is equal to 1 by 2 pi FC, where FR square is equal to 1 by 4 pi square LC. What is the resonant frequency formula is 1 by 2 pi root LC. And coming to one problem, a coil of 5 millihenry inductance and L is equal to 5 into 10 to the power of minus 3 Henry, and 10 ohms resistance R is equal to 10 ohms connected in series with the 5 microfarad. Determine frequency at which the circuit resonates. This is a RLC series circuit, RLC, and RLC values are there. Observe that the resonant frequency is independent of the resistance. So substitute the values 1 by 2 pi. L value is 5 into 10 to the power of minus 3, and C value is 5 into 10 to the power of minus 6. Then finally I got it as 1.0065 kilohertz. So this is the answer, 1.0065 kilohertz. And so properties of resonance circuit. So the first one is, what is XL? XL is equal to omega L, and this should be equal to 2 pi FL. So if you draw the curve between inductive reactance versus frequency, as the frequency increases, XL is directly proportional to frequency, as the frequency increases, XL increases linearly, and XC is equal to 1 by omega C, 1 by 2 pi FC. As the frequency increases and the XC value will be decreases, this is an exponential rise. This is called XC versus frequency. So I require minus XC. Minus XC means that should be equal to minus 1 by omega C minus 1 by 2 pi FC. If FL value is 0 and it is minus infinity, and it will come in like this. So now I am combining XL waveform and minus XC waveform. XL minus XC waveform you can observe, and I am drawing with different colors. So this is the XL waveform, where XL is equal to omega C, and one more waveform is XL, this is a minus XC waveform. So add these XL and minus XC, then I will get the XL minus X. So add these two. 0 minus infinity is infinity, and it will be increases linearly. At particular time, XL value is equal to XC, and this is called the resonance condition. So before that, negative value is far greater than that of the positive value, then I am getting the negative only. So below resonant frequency, it acts as a capacitive circuits, or capacitive is dominating. At lower frequencies, XC is greater than XL. At higher frequencies, that means above the resonant frequency, XL is greater than XC. So in this portion, XL is greater than XC, but in this portion XC is greater than XL. And this is the reactance curves. So properties means the first one is the reactance curves of XL and XC, XL minus XC. And after that, variation of impedance, how the impedance value will be changes and current. So Z is equal to R plus J into XL minus XC. At resonance condition, XL is equal to XC, the Z value is equal to R. See, something, suppose 5 plus something is greater than 5. So I can say that it is Z minimum is equal to R, because R plus something is greater than that of the R value. So the current is equal to V by Z if the denominator is minimum and the current is maximum. If you want to draw the curve, impedance versus frequency, at a resonant frequency F is equal to FR is equal to F naught, what will happen? The impedance value is minimum. After that, frequency increases, the Z value magnitude is also increases. So before that, at lower frequencies, XC is greater than XL. At higher frequencies, XL is greater than XC value. So if you observe the 5 plus something is greater than 5, right? Yes or no? This value will be more, and after that, as the frequency increases, the Z value will be decreases to R. Again, as the frequency increases after resonance condition, the Z value will be increases. It looks like a V shape. And coming to the current, so current versus, if I am representing current versus frequency, and current and impedance both are having inverse relationship. See here, exactly in inverted V. So inverted V. This curve is called the current versus frequency, and this red line is called the impedance versus frequency. And this is the characteristics or variation of the impedance and current.